Hello everyone and welcome to another Math tutorial video. Now I'll be discussing Form 5 Additional Mathematics Chapter 2 Differentiation Long Question Example 7. Okay, before that, please like this video to show your support and subscribe to the channel for more upcoming mathematics tutorial videos in the future. Okay, let me read the question now. In the diagram, the equation of the straight line RQ is 2y plus x minus 8 equals to 0. P is a variable point on the x-axis such that PQ is always parallel to the y-axis. The length of OP, which is equals to A units, such that 0 less than equals to A less than equals to 8, and the length of OP is increasing at the rate of 0.1 unit per second. Okay, so continue to read for the question part A. If the area of the shaded region is A centimeter square, show that A is equals to 1 over 4A in a bracket 16 minus A. For the question part B, find the rate of change of the shaded region when OP is equals to 3 units. So this is the overall question. So I hope that you will attempt this question in the future. If you could manage to solve this question, a big thumbs up to you guys. But if you can't solve this question, no worries. I'm going to show you the step-by-step working and the solutions. So without further delay, let us start to solve the question. Let us begin our discussion for the question part A, where we need to prove that the area of the shaded region A is equals to 1 over 4 A in a bracket 16 minus A. Okay, so to solve this question, take a close look at the area of the shaded region. This area of the shaded region is actually look like a trapezium. Okay, so to solve this question, the first important thing that we need to know is we need to know the area of the trapezium. Okay, so let me write down the area of the trapezium over here. So area of trapezium is equals to half, and then you times with the sum of the two lengths, which usually they will denote as A plus B. Okay, and then you times with the height of the trapezium. Okay, in this case I denote as letter H. Okay, let me box this formula. So by understanding the area of trapezium and the formula, then only we can able to proceed to the next step, guys. Okay, so take a close look in the diagram again. So the height is given as A, but then we don't know the two lengths. Okay, so in order to find the two lengths, we're going to use the straight line equation RQ as our reference. Okay, so from here, the straight line equation RQ, so we're going to convert in terms of the y equals to mx plus c form. So from here, 2y is equals to negative x plus 8. So from here, y will be equals to negative half x plus with 4. Okay, so far so good. So from here, what we're going to do is we're going to find the length of the two sides. Okay, let us start with the length of OR. Okay, the longer one. Okay, so in order to find the length of OR, so the easiest thing that we can do is we can find the y-intercept of RQ. So this will be easy for us to find the y-intercept of RQ. So in order to find the y-intercept of RQ, so what you're going to do is we're going to set our x equals to 0. So when x equals to 0, so your y will be equals to negative 1 over 2, then you times with 0, okay, and you plus with 4. So from here you should get your y is equals to 4. So this is your y-intercept. Okay, let me underline this. So from here you know that your y-intercept of RQ is 4. So from here you should know that the distance between OR is 4 units. Okay, so let me label this as 4 units. At least it will be easy for us to calculate the area of trapezium later on. So let me label this as 4. Okay, let me write this properly. Alright, so this is actually 4 units. So that is our first length So once you get this, we need to proceed with the second one, which is the shorter length. So how are you going to find this shorter length? At least for the first one, we can use the y-intercept as the reference. So how are we going to find the second length? So for the second length, we're going to use the x coordinate instead. Okay, so in this case, we're going to use the x coordinate as point A. So as you can see here, the distance between point O and P is A units. Okay, so we're going to use the A as our reference in this case. Okay, so when x equals to A, so from here you substitute the A into the straight line equation. So from here y will be equals to negative 1 over 2 times with A plus with 4. So from here you get y is equals to negative A over 2 plus with 4. So from here what we do is we combine these two expressions into one single fraction. So from here you get y is equals to negative A plus 8 over 2. Okay, so let me underline the fraction. So from here we can easily find our second length, guys. Okay, so distance between the point P and Q is negative A plus 8 over 2. So let me label this. Negative A plus 8 over 2. So I hope you understand the working till now. We have already get the length of the two sides and we know the height is given as A. So we can use this information to calculate the area of trapezium by using the formula given. Okay, so from here let us calculate. So in this case we're going to calculate the area of the shaded region in reference to the A, guys, letter A. So in this case letter A representing the area of the shaded region. So letter A is equals to half times with, okay, let me use a square bracket, negative A plus with 8, okay, and then over 2 plus with 4, okay, and then a square bracket, and then you times with letter A. Okay, let me underline the fraction over here. So from here, the two expression you combine together with a single fraction. So from here, A will be equals to 1 over 2, okay, times with negative A plus with 8 plus with 8 over 2, okay, close bracket, and then you times with A. Let me underline the fraction. So since we need to prove the area under the shaded region similar to the expression over here, so what you're going to do is we're going to move this A next to the 1 over 2 here, guys. Okay, since everything we are going to times together, so it is considered the same. Okay, so we're going to move this A over this side. So from here A will be equals to 1 over 2 times with small letter A, okay, and then square bracket. So you solve the inside bracket. So from here you get negative A plus with 16 over 2. So let me outline the fraction. Okay, so you're very close to our final answer. So from here, the next step what you're going to do is we're going to factor out the 1 over 2 and then we're going to times it with this constant over here. So from here, area under the shaded region will be equals to 1 over 4 times with A, and then with the square bracket negative, wait a second, okay, let me draw a normal bracket over here. So from here negative A plus with 16. Okay, So it is similar to the final answer, but if you wish to follow exactly the expression over here, also no problem. Okay, so you can rewrite this as 16 minus a. Basically is the same. Okay, so we have successfully proved that the area of the shaded region as a is equals to 1 over 4 small letter a in a bracket 16 minus small letter a. Okay guys, so let me underline the solution for the question part A. Okay, this question, it might look complicated, but you just have to know the area of trapezium, and then you find all the lengths required, and you just have to calculate the area of trapezium, and then you should be getting the expression over here. Okay, so let us proceed our discussion for the question part B, where we require to find the rate of change of the shaded region when OP is equals to 3 units. Okay, let us continue our discussion for the question part B. Okay, so in the question they have already mentioned that the rate of change of length OP is increasing at the rate of 0.1 units per second. So in this case, your length of OP is actually in a form of small letter a. So throughout the discussion, so we're going to address it as small letter a, guys. So from here, d small letter a over dt is equals to 0.1 unit per second. Okay, let me underline the fraction. Okay, and then we have already find the area under the graph expression in the question part A. So let us write it down over here, where a is equals to 1 over 4 times with small letter a in a bracket 16 minus a. So for the next step, what we're going to do is we're going to differentiate this area with respect to small letter a. Okay, because once we differentiate this, then only we can proceed to find the rate of changes. So we're going to use the chain rule to find the rate of changes, guys. Okay, so to differentiate this, you can use two approach. Either you times this straight away and then you differentiate it, or you can use the products rule. But in this case, I recommend you to times straight away and then you differentiate it, so it will require a shorter time. Okay, so from here you times in straight away. So from here you should get a is equals to 4a minus 1 over 4 a square. You can wish to write like this also, 4a minus a square over 4, but it is better to write in this form, so it will be easier for us to differentiate later on. Okay, so let us perform the differentiation. So you differentiate the area with respect to a. So from here you get 4 minus 1 over 2 a. Okay, let me underline the fraction over here. So the 4a you differentiate, you get 4, and then 1 over 4 a square. So the 2 you times with negative 1 over 4. So that's how you get negative 1 over 2a. So from here we have already get the second information. Okay, let me underline this. So the question is asked us to find the rate of change of area with respect to time, which in this case is dA over dt. Okay, so technically that is the one we are finding now, so we don't know yet. Okay, but then we can find this using the chain rule method. So from here dA over dt will be equals to dA, okay, which in this case d area over dA times with dA over dt. So can you see the chain rule form? So this is the chain rule that we are going to use to find the rate of changes. Okay, so from here the question already mentioned that use the condition where the OP is equals to 3 units. Okay, by the way, don't get confused, guys. Then you can ask me, you mention here A and then you suddenly mention here OP. Basically it's the same. So OP is actually equals to A. Okay, so from here, when OP is equals to 3 units, so from here dA over dt is equals to 4 minus 1 over 2, then you times with 3, okay, because you substitute the 3 units over here, okay, close bracket, and then you times with 0.1. Okay, you calculate everything, you should get your dA over dt, which in this case the rate of area with respect to time is equals to 0.25 centimeter square per second. So this will be your final answer. Okay, then you can ask me, why don't you write 0.25 unit square? So please take a look at the question carefully. They mentioned that area of the shaded region is a centimeter square, not a units square. So I hope I've cleared your doubt, guys. Okay, so let me underline the solution for the question part B. Alright, so that is all for the step-by-step working and solution for this question. I hope you understand the full working that I've shown to you. If you like this video, please give your thumbs up. If you haven't subscribed to the channel, please subscribe to the channel and hit the bell icon for more upcoming mathematics tutorial videos in the future, and not to forget to share this video. Thank you everyone for your support, and I will see you in the next video.